Lesson 19, solving one-step equations by adding or subtracting. An equation is a statement that uses an equal sign to show that two quantities are equal. Equal is in this word here, equation. It has that first part, equal, and for it to be an equation there has to be an equal sign. Sometimes we get confused between equations and expressions. An expression does not have an equal sign where an equation does. Okay, a solution of an equation in one variable is a value of the variable that makes the equation true. So, for example, it says, state whether the value of the variable is a solution for the equation. So, to tell whether or not this works, we can I can solve by substitution to see if it's really true that one side is equal to the other. So in this case, x, I have 6, which I'm going to plug in using parentheses, plus 7 equals 13. Well, 6 plus 7 equals 13. And this is saying that 13 equals 13, so that checks out. That would be true. It's a solution, yes. On this one, same situation. I'm going to substitute for y. Instead of y, I'm going to put 12 because they say that y is equal to 12. Minus 4 equals 9. 12 minus 4, that gives me 8, equals 9. Does 8 equal 9? No. So we say no, that's not a solution. Okay? So we're going to do some extra practice with this. What I'm trying to do is I'm trying to get the variable by itself. And to get the variable by itself, that means I have to move everything away from the variable. So if I have x, like in this case I do, and 3 is being subtracted from it, well, the opposite of subtracting 3 would be to add 3. So what I'm going to do is I'm going to add 3. And what I do to one side of the equal sign, okay, this is my equal sign, what I do to one side I must always do to the other for it to stay true. So since I added 3 here, I'm going to add 3 over here. So 3's here will cancel out to 0. I have x. Bring my equal sign down. 12 plus 3 is 15. Same thing here. My n is on the right side. It does not matter which side it's on. I still want to get everything away from it. So if n is here and 8 is being added to it, the opposite of adding 8 to n would be to subtract 8 from n. And what I do to one side of the equal sign, this is this side, I must do to the other side. So I'm going to subtract 8 from this side. So those will cancel out. 15 minus 8 is 7. And bring everything else down, so I know that n must be equal to 7. I want you to pause the video at this point and try C and D on your own paper, please. On C, we're trying to get k by itself. 7 is being added to k, so the opposite of adding would be subtracting. So I'm going to subtract 7. What I do to one side of the equal sign, I must do to the other side of the equal sign. So those will cancel out. I have k equals 13 minus 7 is 6. Final answer. On D, p is right here. 9 is being added to it. I want to get p by itself, so I'm going to do the opposite, which is to subtract 9. What I do to one side of the equal sign, one side of the equal sign I must do to the other, so I'm going to subtract 9 from over here. So 9's will cancel. I bring my p down. Negative 21 minus 9 is going to give me negative 30. Final answer. On this one, fractions work the same way as whole numbers do. We're going to do the exact same process. So I have x plus 1/4 equals 3/8. To get x by itself, I have to do the opposite, so I'm going to subtract 1/4. What I do to one side of the equal sign, I must do to the other side. So I'm going to subtract 1/4 from over here. So my x comes down, my equal sign comes down. And I can't do the subtraction right now because I don't have a common denominator. So between 8 and 4, a common denominator would be 8. So I have 3/8, and I'm still subtracting. I have to have something over 8 here. 4 goes into 8 2 times. 2 times 1 is 2. 2. So 3/8 minus 2/8 is going to give me 1/8. Final answer. It is also important that you always have the variable equal to. This is what tells me what your final answer is. Do not just give me 1/8. I need to know that x equals 1/8, because whenever we start working with multiple variables, I need to know which one is which. Final answer here, the temperature in Lubbock, Texas rose 16 degrees Fahrenheit in 1 week to 97 degrees Fahrenheit. At what temperature did the week begin? So it says that it rose 16 degrees to 97 degrees. So if it rose, I know that I'm adding 16, and what it rose to is this 97. So whatever happens over here, 16 is being added to it, and it has to equal 97 degrees. So I don't know what the temperature T was before, but I'm going to find out. So to get T by itself, all I need to do is subtract 16. What I do to one side, I must do to the other. T's will cancel, or 16's will cancel. T comes straight down. That is a 6. I'm really sorry. T comes straight down equals 97 minus 16, which is going to be 81 degrees Fahrenheit. Final answer. That's it for today. Make sure you're taking good notes. I will see you in class tomorrow. Lesson 20, graphing on a coordinate plane. A coordinate plane is made up of two perpendicular lines, which we must remember means that those two lines meet at a right angle, or 90 degrees. Each point on the coordinate plane is an ordered pair, that's what we call it, and it is always in the order of x and then y. You can remember this because x comes first in the alphabet before y, so it is always x and then y. We always use this order to graph points. We go the x coordinate first, so we always start at the origin, which is right here where those two, right here where those two lines meet. Okay, we always go the x first, which is along the x-axis, and then from the point that we move for the y. Okay. Other things that you need to know about the coordinate plane is that this is the first first quadrant, second quadrant, third quadrant, and fourth quadrant. It says to graph and label each ordered pair on a coordinate plane. Remember, we just talked about that every ordered pair is labeled x and then y. Okay, so this is y. Alright, so what we're going to do is we always start at the origin and we go the x distance first. Well, x is 2 and it's a positive 2, so we go to the right 2 times. From this location, we move the y, and the y is positive 3, so we go up 1, 2, 3 times. Okay, now when they tell you to label it, you can label it a couple of different ways. Because they didn't give you a specific point that this is, we will label it by using the ordered pair. I'm having to use my mouse to do this, so it's going to be ugly. So we would say that this is point 2, 3. On B, same exact thing. We start at the origin. The x is 0, which means we don't move to the left or right at all. We stay right at the origin, and from there we're going to go down 5 because it's negative 5 for y. 1, 2, 3, 4, and 5. Okay, and we will label this point as they tell us to, which is 0, negative 5. When there is a relationship between two variable quantities, one variable is independent and the other variable is dependent. The independent value can be chosen, that is the input, and we've already talked about input and output a little bit, I think, and what we need to remember is that input, or the independent variable, is always x, and my dependent, which is the output variable, and that's determined by the input, which you should know that whenever we're substituting in with x and y, we always substitute in for x and solve for y. So that makes y our dependent variable. So it says to identify the independent and dependent variables. I want you to pause at this point, read through them, and see which thing you think depends on the other one. Okay, that's usually the best way for me to figure them out myself. So go ahead and pause. On A, the distance traveled and the amount of gas used. Okay, so does the distance you traveled depend on the amount of gas that you use, or does the amount of gas that you use depend on the distance that you've traveled? I hope that you're thinking that the amount of gas that you use depends on the distance that you travel, which would make the amount of gas the dependent, and the distance that you travel the independent. On B, the water bill and the gallons of water used. Does the water bill depend on the gallons of water used, or does the gallons of water used depend on the water bill? Well, let's think about this. At home, when you get your water bill, I'm sure that it fluctuates every month because it depends on how much water is used. They don't say, okay, this month your water bill is going to be $100, so you're allowed to use this many gallons of water. That's not the way that it works. The water bill depends on the gallons of water that you use each month. Okay? So it says to complete the table for this equation, what you're going to do is you're going to create a t-chart here. T-chart always has x and y. Our x is always on the left-hand side of a t-chart because that's our input. We're going to choose numbers for this and plug them in here. So whenever I choose numbers, I always like to choose a negative, 0, and a positive so I can see what happens with negative and positive numbers. So we're going to choose -2, 0, and 2. So if I plug in -2 for x, y equals 4, and instead of x, I'm going to put that -2. Remember, when we substitute for a variable, we always use parentheses. So I have 4 times -2 first because multiplication comes before addition. So I'm going to multiply these two. 4 times -2 is a -8. Bring down everything that I haven't used. -8 plus 2, that's going to give me a -6, which is what y is equal to whenever x is -2. I want you to go ahead and pause and find the output values for 0 and 2. Okay, whenever you plug in these two things, you should have found that whenever x is 0, y is 2, and that when x is 2, y is 10. If you did not find those numbers, look back and see what you could have done wrong, and if you can't figure it out, please come and ask me tomorrow in class. Final example here. A friend's allowance wages are about $15 per day. His allowance payment from his parents is dependent on him completing all of his given chores for the day. The total allowance can be calculated using this equation, which is y equals 15x. Find the pay when he works 5, 7, 10, and 12 days. So essentially what we're doing here is we are creating a t-chart where x, okay, it says find the pay when he works 5, 7, 10, and 12 days. He's getting paid $15 a day, so x is representing days. So we're going to plug in 5, 7, 10, and 12, okay. So all we have to do is say y equals 15, and instead of x, we're going to put that first value, which is 5. So all I'm doing here is multiplying, and I have 15 times 5, which is going to give me 75. So he will get paid $75 if he works 5 days. I want you to go ahead and finish the rest of these out on your own paper, please. Plug in, solve for y, and make sure you've taken good notes, and I'll see you in class tomorrow.